In this lesson, we are now introducing and beginning working with our indefinite integral. So up to this point, we had been focusing on the definite integral because here our answer was always a number, right? Because it represented the area under the curve from our given interval. So like here, A to B. So we have boundaries given to us. So like 1 to 5, 2 to 9, right? So here we focused on a number answer that represented the area under the curve because we were given our boundaries. So that means now moving forward, the indefinite integral. There are no boundaries. So notice there is no A to B. It's just our function with respect to, in this case, X. So that means our answer is not going to be a number. Our answer is now going to be another function. So here, if I wanted to know, given our function 3x squared, the derivative, right? Notice our notation with our prime. Well, the derivative was 6x. Because here we would bring down, right? We would multiply by our old exponent here and subtract 1. This means if I wanted to know what is the integral of 6x dx, so with respect to x, the integral or antiderivative is, so f of x is 3x squared. Notice they are inverses. They are opposite. So now moving forward, we are doing everything in reverse. Everything is opposite. We're working backwards. However, the main key difference, though, is when finding the antiderivative or integral, this is going to be not just 3x squared plus c, so plus a constant. Like we don't know what the constant is, so we're going to have plus c because, think about it like this. If I wanted to know what is the derivative of not just 3x squared, but let's say 3x squared plus 7, well, the derivative was just 6x, right? Because the derivative of a constant was 0. It canceled out. So this was the same as just doing 3x squared. So again, if I wanted to know what was the derivative of 3x squared minus 150, well, the derivative was still just 6x because the derivative of a constant was 0. It canceled out. So that's why here, this constant, we don't know. It could be any constant because if I wanted to go backwards and take the derivative would still be 6x no matter the constant. So keep that in mind now moving forward here with our indefinite integral. So our power rule. Now you don't have to worry about writing this because this is just going back to our derivative. But here, our step 1 was we would multiply by the old, right? We would bring down and multiply by the old. Then the step 2 was we would subtract 1 from our exponent, right? And then that would be our new exponent. Keep in mind, this is what I now want you to take note of. Our power rule for the antiderivative is the reverse order. But not just reverse order, reverse everything. So like step 2 is now going to be our step 1, but we're not going to subtract 1 first from our exponent. We're now going to add 1 to the exponent. So now we are adding 1. So this is x to the n plus 1. So again, we are adding 1 to our exponent. Then now our step 2 was step 1, but we're not going to multiply by the old exponent. We are now going to divide by the new exponent. So here in this case, we are going to divide by n plus 1. Then, of course, remember now, don't forget your plus c, plus whatever a constant could be. Because again, the derivative of a constant, any constant is 0. But this is our power rule. So here, a couple other new rules. So now remember, right, our derivative of a constant now, or integral of a constant now. So the derivative was just 0. So our integral of k is going to be still keeping k, but now k times x. Then of course, don't forget plus c. So like here, if I had the integral of 6 with respect to x, then the integral is 6x plus c. Because again, if I wanted to know what was the derivative, well, the derivative of 6x is 6. So that's why here we're just adding x to our constant. So like here, this example, even with fractions, if I want to know what's the integral of 1/2 dx, then that is 1/2 x. Don't forget, plus c. Now here, this is not just dx like a 0, it's got a coefficient of 1. So really, we're finding the derivative of 1. So the derivative of 1 is 1x or just x plus c. Then another rule, our sum and difference. So it's the same as like if when we had our definite integral, where we could separate. So again, same thing. We can take the derivative, or I'm sorry, integral of each of our two functions. So this is the integral of f of x with respect to x dx plus or minus, right? Same rule applies for addition or subtraction. The integral of the integral, I don't know what happened here. Let's do that. There we go. The integral of g of x dx. So here, if I want to know what's the integral of x plus 2 dx, right, with respect to x, this is the same as the integral of x dx plus the integral or antiderivative of 2 dx. So here, this is the integral of x. Here, remember, this is x to the first power. So remember now, power rule, add 1. So this is now x squared. But then don't forget to divide by the new exponent, which is 2. Then, of course, plus c. Then plus the integral, well, that's just a constant. The integral of 2 is 2x. Now, plus c. So do we really need to double up on the plus c? No. So this is x squared divided by 2, or 1/2 x squared, plus 2x plus c. That is our integral. So here, let's do another. Again, even with 3 terms, we can still separate. So this is the integral antiderivative of 3x to the 4th dx minus, so again, continuing, all still with respect to x. So here we go. We are adding 1. So this is now 3x to the 5th divided by 5. Minus, add 1. So 6x to the 3rd divided by 3. Plus, remember, right, this is x to the first power, so add 1. X squared divided by 2 plus c. Now let's simplify. This is here, can't divide, so we'll leave it. I'll rewrite it to you as 3/5 x to the 5th. However, negative 6 divided by 3, negative 2 x to the 3rd, plus 1/2 x squared plus c. That is the antiderivative function, our integral. Let's do a couple more. Again, this is here the same as the integral antiderivative of 2x dx minus, and then here our constant. So now we've got, remember, this is original exponent of 1, add 1. Now I've got 2x squared divided by 2, the new exponent, minus, this is just here, our constant of 4, so 4x plus c. Now simplify, because 2 divided by 2 is 1. So really this is just x squared minus 4x plus c. We'll do one more. So again here, remember, we can separate I'll go through each term. So this is add 1. So this is 4x to the 4th divided by 4, right? Because we're dividing now by the new exponent. Here, exponent of 1, add 1, minus 5x squared divided by 2, our new exponent, plus 2x plus c, because again, we have a constant. Now notice we can simplify. 4 divided by 4 is 1. So our integral here, our antiderivative is x to the 4th. So f of x is equal to x to the 4th minus 5 over 2x squared plus 2x plus c. So go ahead and pause the video now and try these three on your own. And here we go. So for the first one, this was just our constant. So this is negative 5x plus c. Then here now, which don't forget, add 1. So 6x to the 6th divided by 6 plus 4x plus c. However, you should have seen to be able to simplify. So f of x, our antiderivative, is x to the 6th plus 4x plus c. Then here, our last integral, add 1 x to the 4th divided by 4. Then here, with an original exponent of 1, add 1 minus 4x squared divided by 2 minus 7x, right? Because of our constant, then plus c. However, you could simplify. So f of x here is equal to 1/4 x to the 4th minus 2x squared minus 7x plus c. So now here, if we have our fractions, right, or radicals, practice rewriting. So here, this is the same as getting the integral of x to the negative 3 dx. Now again, here, just like before, add 1. So this becomes x to the negative 2 divided by negative 2 plus c. But rewrite this. Now notice your negative exponent, so my base here needs to go in the denominator. So this is the same as negative 1 over 2x squared plus c. That is the antiderivative, because again, negative 2, so bring the negative out. X squared goes in the denominator, leaving a value of just 1. So again, let's rewrite. Here I've got 3 times x to the negative 4 dx. So again, add 1. So now I've got 3x to the negative 3, but then don't forget to divide by negative 3 plus c. Now let's simplify. Negative 3 divided by negative 3 is negative 1. So negative 1 over x to the 3rd plus c. Because again, here our base of x has a negative exponent, so it needs to go in our denominator. That is our antiderivative. Now again with our radicals. So here, make sure to rewrite. So this is the same as getting the integral of x to the 1/2 dx. So here we go. Add 1. So now I've got x to the 3/2, right? 3 over 2. But then remember, divide by that new exponent of 3 over 2. So if you recall, dividing by fractions is the same as multiplying by the reciprocal. Oh, I just realized something though. What did I forget? Plus c. So then here, multiply by the reciprocal. So this is the same as 2/3 times x to the 3/2 plus c. That is our integral, our antiderivative. So we'll do one more. Again, rewrite. This is x to the 3rd, but 3/4, right? Because of our 4th root, dx. So here we go. Add 1. So this is now x to the 7/4 divided by 7/4 plus c. Now, of course, let's rewrite this. Remember, this is the same as dividing by a fraction multiplied by the reciprocal. So 4/7 times x to the 7/4 power plus c. That is our integral, our antiderivative. So here, go ahead and pause the video and try these u-tries on your own. And here we go. So for the first one, rewrite x to the -2 dx. So here, when you add 1, you get an exponent of -1 divided by -1. So this is -1 or negative x to the -1 power plus c, or -1 over x plus c. So that is our integral, our antiderivative. So then here to rewrite, this is x to the first power, but 1/3 dx. Here we go. Add 1. So now you've got x to the 4/3 divided by 4/3. Then rewrite this. So our antiderivative is 3/4 times x to the 4/3 power plus c. That is our integral. Last one. So now here, this is going back to just good old power rule. Here I've got 4x to the 4th divided by 4. Now, that is our integral. However, let's go through and get the minus. Let's rewrite this. So 7x to the -5. Then add 1. So this is x to the 4th. I just divided 4 by 4. Minus, so here you've got 7x to the -4 divided by -4. So here, plus c. Now let's rewrite this. So here, notice 2 negatives making a positive. So x to the 4th plus. This is only the x, right, is what's being raised to the negative exponent. So that is what goes in the denominator. 7 over 4, because our 4 here, so 4x to the 4th plus c. That is the antiderivative.